In this lab, we're going to experimentally determine the specific heat of a metal, and we're going to use the heat flow equation. Just a quick overview. We are going to start with a massed piece of metal that we have placed in a hot water bath. The water bath will be near boiling, but it doesn't necessarily have to be. We will take the initial temperature of the metal as it sits in the bath right before we transfer it to a calorimeter. The calorimeter is going to be a styrofoam cup that has a massed amount of water and it has the temperature initially taken. As the hot metal sits in the water, it's going to radiate its heat to the water, and thus as the metal cools down by losing heat, the water's temperature will increase by gaining heat. Eventually, we will reach an isothermal state where the temperature of the metal is equal to the temperature of the water, and at that point, all the heat transfer is done. We then take those temperatures, and that allows us to calculate the specific heat. When using the heat flow equation, you have to account for three variables: the mass, the specific heat, and the change in temperature. Of course, change in temperature is T final minus T initial. Important to note that any loss of energy from the metal is equal but opposite to the energy gained by the water. This is assuming complete thermal transfer, assuming no heat is lost to the surroundings. If we know the energy lost by the metal, we can calculate how much energy was gained by the water, and if we break down the variables for each of the values of Q, that will allow us to isolate and solve for the specific heat of the metal, which is the purpose of the lab. To note, the specific heat of water is 4.18 joules per gram degree Celsius, so that is a known. So first we're going to get the mass of our metal cylinder. The mass is 53.736 grams. Next, we're going to mass an empty calorimeter. A calorimeter is a styrofoam cup in a thicker styrofoam cup in an aluminum cup with a plastic lid. So we're going to weigh all of this initially. $102.263 grams, 264 grams. We're going to add 100 milliliters of water to the calorimeter, and we're going to mass it. $202.526. Next, we're going to get the initial temperature of the water in the calorimeter. We're going to do that using a temperature probe and the lab quests. The water was sitting out in the room, so it had already attained room temperature. So that's why the temperature doesn't appear to be changing, because the water was already at the same temperature as everything else in the room. So we're going to call our initial temperature 22.3 degrees. Now we're going to transfer the metal from the hot water bath into the calorimeter. And to do this, I've placed the calorimeter close so that the metal, after being removed from the water, is not exposed to the air for too long. We will take the initial temperature of the metal in the hot water bath, and it's looking to be just on 95 degrees. So I'm going to reach in with the tongs, place the metal in, close the lid, bring this over, and put the temperature probe into the calorimeter. Stirring the water in the calorimeter to help circulate the water and evenly spread out heat. And we're going to just keep watch until the temperature reaches the highest temperature it can go. We'll know the temperature has reached its peak once it starts to decline again. It seems the water temperature is really not changing anymore. So we're going to go ahead and call this our final temperature. So both the water and the metal now are 26.2 degrees Celsius.